Alright, welcome to the second in our series of review videos. So as promised, the second video is going to be on fractions. Those of you who feel you know your fractions, you're welcome to skip this video, but history has taught us that there are plenty of people who are a little rusty on their fractions and could stand to see a review. So let's dive right in. Um, what are the fractions? Fractions are the so-called rational numbers. These are anything that can be written as one whole number divided by another. So this z here, this stands for the integers. Okay, um, z is coming from the German word for integers, which is Zahlen. Um, so we know what examples of these numbers are. So things like 2/3, 7/2. These are all examples of fractions, right? And by the way, we don't mind improper fractions, ones like this where the numerator is bigger than the denominator. That doesn't bother us. Mixed fractions are a bad idea. Try to avoid them if you can. 3.5 gets a little bit confusing because you might write 3.5 and then you come back to it 5 minutes later and you think it's 3 times a half when it really means 3 plus a half. And anyway, it's just generally a bad idea. Now, of course, not all real numbers are rational. There are also irrational numbers. So most famous example being square root of 2, which I think, I don't know, involves some sort of ritual murder among the Greeks way back in the day. Pi is another example. There are lots of interesting examples of irrational numbers. What's perhaps more interesting is that irrational numbers make up the vast majority of the real numbers, and most of them, we have no idea how to write them down, right? We actually, there's a handful of irrational numbers that we're familiar with, but most of them are pretty mysterious. Now, let's not worry about the real numbers for now. Real numbers, that's a surprisingly complicated topic. We want to talk about fractions. So there's a couple things you need to know about fractions. First is, what does it mean to say that two fractions are equal? If I have, say, a over b, and I want to set that equal to c over d, what does it mean when I say that those two fractions are equal? Well, usually the way we define equality is like this. We say that this equality here is equivalent to kind of saying that the two cross products are the same. A times d is equal to b times c. Okay, that's what it means for two fractions to be equal. So for example, if I had 3/6, that's equal to 1/2, since 2 times 3 is equal to 1 times 6, right? Both of them are equal to 6. Which brings us to this issue of equivalent fractions, and this is something that comes up quite a bit. What do we mean by equivalent fractions? This is simply the observation, which you guys all know, that if I have a fraction, a over b, and I multiply by, well, 1, but I'm going to write 1 as, say, k over k, where k is a number, right? Anything divided by itself is equal to 1. We know that multiplying by 1 doesn't do anything. But I could write this now as a times k over b times k. Okay, and we'll see this issue of equivalent fractions coming up quite a bit. It's going to come up sometimes when we're doing algebraic work, and well, on the one hand, cancellation, where we see that kind of common factor top and bottom, we want to cancel it out to get back to the simpler fraction. And on the other hand, sometimes we actually want to multiply top and bottom by the same thing. Maybe we're trying to rationalize a denominator or something like that, and we want to clear something out. Now, we're usually not dealing with fractions there anymore, but the algebra is the same. The ideas are the same. Okay. By the way, one comment I'll make before we move on. I don't care if you reduce your fractions. If you want to leave a fraction as 3 over 6 rather than 1 over half, by all means do so. I might think you're a little bit strange leaving it that way, but you're not going to be penalized for something like that. Okay, how do you add fractions? Well, the trouble with adding fractions is you can't really combine different fractions, and one fraction is different from another if they have different denominators. So if I wanted to do, let's say I want to do a half plus a third, for example. Well, I mean, one way we might think of that is think in terms of like a number line. Okay, here's 0, here's 1. We kind of go like a third of the way along, so here's 1/3 from there to there. And then I want to add a half, right? Well, how do I add a half? Well, a half would be, I kind of, I would go from here to here. And I got to figure, okay, how do I actually add that on? Well, one way I would probably add that on is I would take this and I would shift it down until I was kind of here, and I'd add that up, and then I would combine the two and say, okay, what's the total? How do I make sense of that total? Well, the way you make sense of that total is you use equivalent fractions. So you take the two fractions you have and you turn them into something that can be combined. If you want to think in terms of the number line, what you can do is you say, well, I can't really compare a third and a half directly, but let me take my 1/3. Okay, here's my 1/2. I'll take my 1/3 and I'll divide that up into 2 pieces. I'll take my 1/2 and I'll divide that up into 3 pieces. Okay. Well, now I have, so this is now, what's the size of each piece? Well, each piece is now a sixth. And how many of them are there? There are 5 of them. So we expect the answer should be 5/6. So how does this work? Well, using equivalent fractions, I look for the so-called common denominator, right? So when you're adding, you need this common denominator. So I look and I say, okay, what's the common denominator here? Generally, you just look for the product. 2 times 3. 2 times 3 is 6. So I say, okay, if I want to get a 6 on the bottom for the first fraction, I need to multiply top and bottom by 3. So 1/2 is the same thing as 3/6. Multiply top and bottom by 3. 1/3, I multiply top and bottom by 2. 1 times 2 is 2. 3 times 2 is 6. Okay. Now I'm adding things that are the same. I'm adding sixths. And if I add 2 things with the same denominator, I just combine the numerators. If I have 3 of them and I add 2 more, well, then in total I have 5/6. Okay. That's the way it works for addition and subtraction. Okay? And the general rule here would be that if I did A over B and I wanted to add C over D, well, I multiply the first one top and bottom by D. I multiply the second one top and bottom by B. And now that the denominators are the same, I can combine them. Okay? And I've added my fraction. Now, if you want to kind of simplify things, you might want to pay a little bit of attention and watch out, because sometimes the common denominator you get by just simply multiplying the 2 denominators is not the most efficient way of doing things. I'm sure you guys have heard of dealing with lowest common denominators. So if I was doing something like, let's say 2/6, and I wanted to add, I don't know, 4/9, let's say. Probably should have, well, 2/6 is a third, but bear with me. So what could I do? Well, I could, if I wanted to, I could multiply the 2 denominators. 6 times 9 is 54, so let's multiply this guy top and bottom by 9. 2 times 9 is 18 over 54. The other one I multiply by 6. 4 times 6 is 24 over 54. And I combine those. So I got to do 18 plus 24, so 42 over 54. And from there you might feel like, hey, I should probably reduce that. You don't have to. You could leave it as that, but it's a kind of an ugly looking fraction, right? So the other thing you could do is you could say, well, is there a smaller common multiple between these two? And you say, yeah, 54 is not the smallest. I could go, let's see, 18 works, right? 18 is 3 times 6, and it's also 2 times 9. And that makes my job a lot easier, because now I just have to multiply top and bottom by 3 in the first one, 6 over 18. And I have to multiply by 2 in the second one, 8 over 18. And now I get 14 over 18, which is a much easier fraction to work with. And in fact, you might notice that those are both even, so if I divide by 2, I can reduce down and I get to 7 over 9. Okay, so not necessary for you to use the lowest common denominator, but it often helps to reduce along the way. It simplifies your life if you can spot things. Multiplication and division. What's the rule? Well, when you're multiplying, you don't need a common denominator here. You just multiply the tops and the bottoms. A times C, B times D, right? I think one of the places where people tend to go wrong is they see this rule for multiplication and they say, hey, that's awesome. That's way easier than the rule for addition. Let's also make it the rule for addition. Well, yeah, if you do that, you're going to go horribly, horribly wrong. Okay, so when you're adding, you don't simply add the tops and the bottoms. We've seen that you got to go through this process of finding the common denominator. But multiplying is easier. You just multiply the tops and the bottoms, right? So if I wanted to do 2/3 and I wanted to multiply that by 5/7, let's say, piece of cake. 2 times 5 is 10, 3 times 7 is 21, and I'm finished, right? The only place where maybe things get, let's say, a little bit more interesting is maybe I have 2/3 and I want to multiply by, I don't know, 15/4, let's say. Well, I can still go straight ahead and I could multiply. 2 times 15 is 30, 3 times 4 is 12, but then I might decide that, hey, you know, I could reduce that fraction. I don't want to leave it as 30/12. I'm going to try and reduce it a little bit, and you can if you want. So one of the ways that you can avoid that trouble of having to kind of reduce after the fact is you can reduce ahead of time, because here you might notice, hey, wait, if I just swap the 2 and the 15, there's no reason I can't swap the 2 and the 15. We know that the order of multiplication doesn't matter. Well, then I have 2/4, and I know that 2/4 simplifies to a half. Similarly, 15/3, 15 divided by 3 is 5. So 15/3, that's just 5, and that's just a 1. Well, that's way better, right? That's way better. Now I simply have to do 1 times 5, 1 times 2, and instead I get 5/2. That's much simpler than 30/12, right? So that's maybe the one thing that you might watch out for when you're doing multiplication. But again, if you leave your answer as 30/12, I'm not going to ding you for it. It's fine. Division. Now, when you want to divide, remember that the way we define division in general for real numbers, when you want to divide by a real number, the way you divide by a real number is you multiply by the reciprocal. And for fractions, reciprocals are easy. You just flip them over. So if I want to take a over b and I want to divide by c over d, I simply flip that over. So c over d becomes d over c, and then I multiply as before. Keep that rule in mind, okay? Division is the same thing as multiplying by the reciprocal. You would be surprised how often it comes in handy when you're a little bit mixed up as to what you should do, right? One of the places where you kind of end up getting mixed up with something is you know, I have, let's say I have 2/5 and I want to divide by 2, right? And you think, okay, divide by 2. Where should the 2 go? Does it go on the top? Does it go on the bottom? Where is that 2? Well, what is 2? 2 is really 2/1. So really, dividing by 2/1 is the same thing as multiplying by 1/2. And well, now I can see what the answer should be. It should be 2/10, or if you like, 1/5. Okay. Before we wrap up, I know this is dragging on a bit already, but before we wrap up, let's say a few things about this, how this comes into the algebra picture, okay? This is probably like the most common mistake that people make when they're doing algebra in a calculus course, which is they don't reduce correctly. So let's say I have to reduce an expression like x squared over x cubed plus x squared, right? Something like this. Now, a lot of people, they see this and they see the x squared on the top and they see the x squared on the bottom and their eyes get really big and they pull out that red pen and they get ready to cancel. And if you do, totally wrong. You're not going to get the right answer, okay? So you can't just cancel those guys, leave that x cubed behind. Try plugging in a few numbers. You'll see that it doesn't work, okay? How do you cancel? You can't cancel terms. If there's addition involved, right, this plus sign here is what's causing trouble, right? If things are being added, you can't simply cancel something. The only way you can cancel is when everything is being multiplied together, and so the way you have to turn this into a multiplication situation is you first pull out common factors and then you try to cancel. So on the bottom I can say, all right, there is an x squared that I can cancel, but first I have to factor it out. X cubed is x squared times x. X squared, of course, is x squared times 1. Okay? Now that I've pulled that factor out, that x squared, now I can cancel. Okay? And be careful, it doesn't leave you a 0 on the top, it leaves you a 1, right? X squared is really x squared times 1. And now I cancel those x squares, right? This is this whole similar fraction idea, right? Or equivalent fraction. I can multiply top and bottom by the same thing without changing the value. And so the correct reduced value here is 1 over x plus 1. Okay, so the warning I'll give you is do yourself a favor now and just give yourself a reminder, sticky note, do whatever you do, and just give yourself that warning of be very, very, very careful. Anytime that you cancel, ask yourself, am I allowed to cancel this? Am I doing the right thing? Or am I doing it wrong? If you're in the tutorial, you're in class, you're not sure, feel free to ask. Say, am I allowed to cancel this? And we'll let you know. Okay. Well, you know what? I already gave you an example, and this video is getting too long. So let's stop with this. I could give you an example of what not to do, but sometimes that leads to trouble. So let's leave it at that, and we'll move on to the next video. All right.